then plus 3 left over. And I'm done. Okay. All right, now let's move on to the next problem. I've got number 18 here. So it says, write an expression to represent the area of the shaded region, okay? So they don't want to know the area of the whole square or the whole rectangle. They want to know just the shaded region, okay? So I'm going to have to find the area of both of those shapes in order to get the area of just one of them, okay? So I'm going to start with talking about what the area of a rectangle is. So remember, area equals length times width or base times height, whichever one you prefer. So I'm going to use that formula to find the area of this rectangle, this shaded one here, okay? So that means I'm going to have to say area equals x times x plus 2. And you know from our time in class that whenever I have something on the outside of parentheses, I'm going to have to distribute. So that means that is the area of my larger rectangle right there. Okay, but now I need the area of this smaller rectangle, okay? And actually we're lucky here because it's got constants there. So when I find the area of it, I'm going to use 3 times 7, and we know that that is 21. So in order to find the area of that larger region, I need to be able to find its area and then cut out that smaller region. It's like if I had a piece of construction paper, took the area out of it, and then cut a piece from it. That's exactly what we're doing here, okay? So let's find the area of this so let's take the area of that larger one, which we found to be x squared plus 2x, and then we have to take away that smaller region, which was minus, because I'm taking it away, and then 21 was its area. Now, the next step in polynomials is always to combine like terms, but in this problem, I don't have any. So that's actually the end of your problem. That is how you're going to represent that area taking away that smaller area. Okay, so you're done. And you can put equals area if you'd like. All right, let's go to number 23 now. So on number 23, this section is actually on factoring, so that's what I'm going to be doing for number 23. So the first thing I notice is it has 4 terms. And then I also want to see if I can bring out a greatest common factor out of any of those. And from what I can tell, I can't. So I'm going to go ahead and divide it into 2 parts. And I'm going to take the greatest common factor out of the left side first. So the greatest common factor out of those 2 would be 4. And then I can also bring out an x squared. And what is left over is an x plus 3. And then if I want to go over here to the next side, negative 25 and negative 75 both have a negative 25 in common. And then x plus 3 would be left over. So now I have my groups. So I'm going to have 4x squared minus 25 and x plus 3. Now, you could say, well, we're done here, but there's something I want you to notice here, because look at this 4x squared minus 25. Okay, there's still something very important in there, because I have 2 perfect squares and a subtraction sign there, so I can actually do difference of squares factoring. So that means I'm going to take this and I'm going to make 2 new groups, and I'm going down in this next box, so just forgive me for that. The square root of 4 would give me 2, so I put that in both. The square root of x squared is just x, and the square root of that 25 would be 5. A plus, a minus, you're done. And then, of course, we have that x plus 3 with it. Okay? So, to clean up my problem, I'm going to get rid of this 4x squared minus 25 and change that to 2x plus 5 and 2x minus 5. And I'm done. Okay? All right. Let's move on to number 29 here. So this time we're dividing polynomials. So I'm going to actually rewrite this problem because you guys know how I am. I like to have mine look a little neater. So I'm performing a division problem here. So the first thing that I want to do is I want to factor out that top number, because I'm noticing a couple things here. First of all, I see that there are 2 terms. But I also see that there's a subtraction sign and there are 2 perfect squares there. So that means I can do that difference of squares again. So take the square root of x squared, that gives me x. Take the square root of 9, that gives me 3, plus minus, and it's still over x minus 3. So if you remember from class, now that I factor that out, now I can do the dividing part, and all I have to do is I know that x minus 3 divided by x minus 3 is 1, so I can get rid of those. And so my final answer would be x plus 3. All right, now that was not covering all of our factoring problems, I know that, but these are the ones that I kind of just wanted to go over real quick, and you guys will have a few of these on your exit ticket for today, or not these exact problems, but similar to that. So I just wanted to go over that and make you feel a little more comfortable with those older problems. Let me know if you need any more help.